Okay, back again. This is Chapter Test 2, Part B. I'm going to go through the start of the short answer questions, questions 1, 2, and 3. First of all, simplify the following. So here we are doing multiplication in our first example. So that's great. Multiplying is easy. Number by number, letter by letter, that's all you have to do. So negative 2 times 4. Well, negative times a positive is negative, and 2 times 4 is 8. A times C times B times D. Well, I don't double up on any letter, so I just write them all next to each other. A, B, C, D. It's great if you put them in alphabetical order. You don't have to, but it just helps you keep organised when you're doing them later on, so it's not a bad way to go. I was trying to rub something out then, but for some reason it didn't want to. There we go. Make that D look just that little bit nicer for you. Okay, what about the next one? Division. Same procedure. Letter by letter, number by number. 3 and 9. We look at the 3 and 9 first of all and we say, do they share a common factor? Well, of course they do. 3 goes into 3 once and into 9 3 times. Then I look at my A's. On the top I have A squared. That's 2 A's being multiplied together. I'm also dividing by 1 A. So A is a factor of that. It goes into A once and it goes into one of those. So I'm just left with 1 A on the top. Finally, I've got 1 B on the top. And on the bottom I've got 2 B's being multiplied together, so one of those B's down the bottom can cancel out with a B on top. And on top I've got 1 times A times 1, which is of course just A. And on the bottom I've got 3 left over out of the 9. The A disappeared to a 1, so 3 times 1 is 3 times B. So it's A divided by 3B. All you do is you cancel the common factors. The next one should be easy, but a few of us have been getting ourselves confused. Here we've just got to collect our like terms when we're adding or subtracting. We can only add or subtract like terms. Remember our Year 9 golden rule of algebra. So this is an AB term. That's not got the same letters because that's got a B squared term. BA and AB are the same, so that's going to match up with that one. B doesn't match up and AB squared doesn't match up with that. But negative 8b squared a, so that's got 1a and 2 b's. This one at the end had 1a and 2 b's, didn't it? So they go together. The negative 2b, it doesn't have a partner, so it's not going to simplify or change. It's going to stay the same. Dealing with the yellow bits first, 5ab plus another ab, that must be 6ab altogether. Negative 8ab squared plus 6ab squared. Negative 8 plus 6 is a net result of negative 2. AB squared, and you can write AB squared or B squared A, it doesn't matter. And finally, the bit that was on its own, minus 2B. And that's all you have to do for those ones. Don't try and overcomplicate it. Here we've got 15A minus 18AB divided by 3B plus 12B. Where's the trick? We've got to do our division first, don't we? 18AB divided by 3B. Well, 18 divided by 3 is 6. There's an A on top, there's nothing, no other A it's being divided by, but B divided by B, that's 1, so they're going to cancel out. So that middle term, instead of writing 18AB divided by 3B, I can just make it 6A. So now I have 2 like terms there, don't I? I have 15A minus 6A. 15 minus 6, last time I checked, that was 9, so it's 9A plus 12B. A little bit tricky there, but not too bad. Hopefully that helps. Let's go on and have a look at question 2. Expand the following, simplifying where possible. I use my distributive law and just multiply the term in the front of the bracket with each term inside. So negative 4 times x, negative 4x, negative 4 times positive 7, negative times a positive is a negative, 4 7s are 28. Same with the next one. 3x multiplied by 4, 3 4s are 12, and I've still got the x there. The next one, 3x multiplied by negative x, so my answer is negative 3, and x times x, how do we write that? You got it, x squared, that's correct. Next one here, 6xy minus 2y times 3y minus x. Expand the bracket first. You've got to do multiplication there before I do any subtraction. So I leave the 6xy alone. And if you need to show extra working, just do it like I'm doing now. Negative 2y times 3y. Negative 2 by 3 is negative 6. And y times y is y squared. negative 2y times negative x, so a negative times a negative is a positive, 2, and the letters in alphabetical order are xy. What have we noticed, of course? I've got 6xy there, 2 of them here, so they can be joined together. How many of them have I got all together? Well, 6 plus 2, last time I checked, is 8. So it's 8xy minus 6y squared. Lucky last here, expand the brackets first. 5 times x is 5x, 5 times negative 3 is negative 15, plus 2 times x is 12, 2 times negative x is negative 2x. Identify your like terms, and if you just went through with a highlighter and highlighted terms that were like and did that correctly, I'd give you half of the mark for that step, even if you messed up them adding or subtracting later on, but you're not going to mess any of it up. 5x minus 2x, that's easy enough, that's 3x, and negative 15 plus 12, well, that's just negative 3. All right, last questions for this page. How do I solve all linear equations? I simply perform inverse operations to isolate the unknown. My guiding principle is that whatever I do to one side, I do to the other. And as a general rule of thumb, we get rid of whatever's got the least to do with the letter first. So here we go. 3x plus 2 equals 17. I want to get rid of that 2. It's got less to do with the x and the 3. It's like the outer layer of clothing when you're undressing. Remember that simple analogy. I keep going back to it because it works. So now I'm just left with 3x on the left-hand side. The inverse of adding 2 is to subtract 2, so they've cancelled each other out. 17 minus 2 is 15. What do I do now? Well, to get x on its own, I divide by 3. So I go ahead and do that, and I have x equals 5. The next one, x over 2 minus 1 equals 6. Well, the 1 has less to do with the x. It's a separate term, so I'm going to get rid of that first by adding 1. Add 1. Doesn't look like much of a 1. Let's make it look a little bit prettier. Add 1 to each side, so now I'm left with x divided by 2 equals 7. What's the opposite of dividing by 2? I could nearly hear you responding. Multiplying by 2, of course. So to get x on its own, the equivalent expression is x equals 7 by 2, 14. Part C, 7 minus 6x over 3 equals 9. Well, the 3 is separate underneath in that denominator, so I want to multiply by 3 to get rid of the denominator, because you can always cancel common factors there, numerator and denominator. So then I have 7 minus 6x equals, and 3 times 3 is 9. You know the drill. Subtract 7 from each side. What does that leave me with? I've got negative 6x equals 2. Opposite of multiplying by 6 is to divide by negative 6. So I go ahead and do that. X, oh, the pen color didn't change. Try that again. X is equal to 2 divided by negative 6, or the positive divided by a negative is a negative, and 2/6 is the same as 1/3. Finally, if your letters are on both sides of the equation, what do? You get them on one side. How do you do that? We'll find the smallest one, 9x, 4x. 4x is smaller, so I'm going to subtract 4x to get rid of it from the right-hand side. I do that so that I keep my x's positive. If all of my x's are going to end up here on the left, I don't want the negative 8 there, so I'm going to do the inverse of that, which is adding 8 to each side. So in one quick little step, 9x minus 8 equals 4x plus 7 becomes 9x minus 4x is 5x, and 7 and 8 is 15. 5x equals 15, you know the answer, but let's make sure we're showing our working. To get x on its own, I do the inverse of multiplying by 5, which was, of course, to divide by 5, and I have x equals 3. There you go, that's part B. Questions 1, 2, and 3 up to part D. I'll get on to page 3 of the test next. Keep up the good work.